All right, so objective 2, now let's solve a problem involving probabilities and a sampling distribution of the sample mean. So it says, suppose the number of texts during a typical day by the population of students at a large high school follows a right-skewed distribution with a mean of 45 and a standard deviation of 35. How likely is it that a random sample of 100 students will average at least 50 texts per day? So they make it apparent to tell you that the population is right-skewed distribution. That means that it's non-normal. Okay, so let's approach the problem like we would. Let's identify the mean of the population. That's going to be 45 texts per day, right? Texts per day. The standard deviation of the population is 35 texts per day. Okay, so we can find the mean of our sampling distribution x bar. It's going to be equal to the population mean, 45 texts per day. To find the standard deviation of our sampling distribution of x bar, we are going to take the 35, which is the standard deviation of the population, but we're going to divide it by n. And n, right here, sample of 100, n is 100. Square root of n. That's going to come out to be 3.5 texts per day. Next, we have to identify whether this sampling distribution of x bar will be approximately normal. Well, when you're dealing with means, if you come from a non-normal population, you have to look at the sample size. N is 100. Remember, the magic number is 30. That is at least 30. Because of this, our sampling distribution for x bar will be approximately normal, and that is by the CLT. Okay? So now we need to look at our probability statement, z-score, or standard normal distribution. So I'll try to do it over here so I don't have to, switch screens. So we want to find the probability. So how likely is it? That means what's the probability that will average at least 50 texts per day. So we're trying to find the probability that our sample mean x bar is at least. That means 50 is the smallest, but it could be more. That's greater than or equal to 50. That's our probability statement. Well, to find our z-score, we're going to take this value of 50. We're going to subtract the mean of our sampling distribution, 45, and divide by the standard deviation of our sampling distribution, which is 3.5. And I'll do this in a dinky calculator. The top's going to be 5. 5 divided by 3.5. Rounded to 3 decimals, I got 1.429. It was 8.5. The 5 makes the 8 become a 9. So now our real problem is find the probability that z is greater than or equal to 1.429. And we'll do this on the probability stats applet. Let me take a picture of that z value so I don't forget it. Again, my memory has all these numbers going through it. Okay, so let's go to the probability stats applet. Statistics, probability. This is a normal distribution. We're calculating an area because we're finding a probability. Our mean and standard deviation is always 0 and 1. There's my standard normal distribution. My inequality symbol is a greater than or equal to. That's to the right. And our value is 1.429. When I calculate that area, I get 0.0765. So the probability that z is greater than or equal to 1.429 is equal to 0.0765. That is your answer. And then again, don't forget to copy and paste this graph. Okay, so again, it's the same as section 6.5, except when you see that the population is not normal, you have to then show me that the n size, the sample size, is at least 30, and mention that it's approximately normal by the CLT. All right, thanks for watching, and good luck on the homework.